attraction design, they manufacture, they system integrate, they construct, they install, they commission, and they execute the regulatory approval of attractions, including amusement rides and show components from multiple manufacturers. And they are sourced from around the world to be operated at venues ranging from major fixed-site theme parks to traveling carnivals. So we have a lot of technology and engineering here. Some branches of engineering specialize explicitly in an application domain like automotive or aerospace, but there isn't any specific theme park engineering program, nor is it likely that one will ever exist. So this presentation and paper begins a discussion of complementary theme park engineering studies that students might take. So engineers contribute to attractions design, and hospitality and business and creative design and production students can and do find undergraduate studies, whereas engineers cannot. There are ways that students get experience through extracurricular and co-curricular activities. Now, engineers can readily work across domains by ethically applying engineering knowledge, and they can sort of figure out a domain on their own, but they're doing this, each one of them is doing this, developing it on their own. To a non-engineer, engineering may seem to be a singular profession, but to an engineer, it's a myriad of different specialties. So the branches do share commonality in engineering, math, science, engineering analysis and synthesis, and of course business ethics and legal compliance, and ultimately the paramount duty to the welfare of the public. I like to say that engineering is the profession that's deputized and made responsible for protecting the public from science. So that's basically engineering in a nutshell. But engineering students commit early in their education to a branch of engineering, such as civil, electrical, mechanical, or industrial, and after that point, never the twain shall meet. They move off and specialize in their own field. And then within their field, each trainee will follow their particular interest within their branch of engineering, through which many professional opportunities and mentoring and reinforced by experience and accumulated knowledge will happen. So they might obtain specialized knowledge in several subfields, but they're typically related subfields. So if you look under the mechanical engineering, which is the yellow-orange one, they might go into thermodynamics, they might go into machine design, they might go into automation and robotics, they might dabble in multiple of those, but they won't tend to also do wastewater and roadways and that sort of thing because they're in different branches of engineering. And yet, theme parks and attractions will use engineers from all the branches. The curriculum for each branch is accredited to its own educational standard through entities like the Accreditation Board for Engineering and Technology, ABAT in the United States, or the Canadian Engineering Accreditation Board, or other regional counterpart. In one engineering program, for example, students have 46 courses to take over 4 years, and the focus is on meeting those accreditation standards, which means they are learning about general principles applicable to any technologies and not about specific types of technologies, let alone specific devices. Professional engineering does have those legally enforceable obligations, so it's very important, and the standards are very, very high. In Canada, the universities are responsible for examining all technical knowledge to the acceptable standard. Even within one branch of engineering, you are limited to how many electives you can have, because the Canadian graduate goes out and becomes a professional engineer after a certain amount of experience time. In the United States, educational programs don't do that gatekeeping role. The students have to write examinations down the road if they want to become a professional engineer. So you do see more U.S. Engineering students having the option to take more electives and minors. However, their school may not offer those other courses that they could take to create their own theme park minor. So this is a first stage of a study that I've been working on observations from several contexts of learning and teaching and engineering education, including my experience directing and producing an international student competition with over 800 alumni to date, many of whom were engineers. And if any of you are from a university that has a theme park club, engineering, or other fields, please be in touch with me if your team would like to join this competition. We start getting in touch with schools in March-ish. For that competition that occurs in November, just before the week before IAPA. I've also had experience mentoring engineering students in theme park club activities, arranging dozens of behind-the-scenes tours and construction site visits, resourcing students, attending industry roundtable events, and supervising student projects. Future steps of this exercise will include reviewing in-service education needs as determined by employers of engineering graduates and qualitative data collected from engineers at various stages of experience. However, based on these things, what I've observed is this. Engineering students have strong skills in engineering analysis and researching the function and structure of amusement rides and devices. They're aware of types of components used and available and types of calculation for things like load and strength. Many of them are familiar with applicable standards. Sometimes they use outdated editions. They're not aware that we renew these standards every single year. We update the standards. And they can combine the knowledge that they have into innovating new device functions. The competition has really showed that there's a lot of creativity and innovation. There are also some gaps, though. Many engineers need to understand the experiential purposes of the devices that they're designing. They need to design devices that will enhance the entertainment and not be obnoxious or detrimental to the entertainment. They need to deliver experiences with minimal risk. If risk outweighs the creative intent and the payoff of the creative experience, it's not justifiable. They need to include human variability rather than itemizing a narrow set of requirements. And they need to understand the business purpose of attractions. They need to plan for capacity, to have adequate capacity to provide the payoff and return on investment. They need to design for efficient operations so that it doesn't take, a cast of thousands to make the machine functional. And yet, engineers need to learn the roles of other professions and trades and artisans. Some of it comes from the misunderstanding of the portmanteau word of Imagineering, because the ineering part suggests to engineers that it's theirs. And like, all you guys are talking about Imagineering, and most of you are not engineers, and you're legitimately doing Imagineering. The ineering part suggests to engineers that engineers do it all: art direction, show producing, concept development, landscape architecture, story writing, etc., rather than a team of diverse experts in different fields and skills, including engineering, that collectively develop a project. Many engineers interested in the industry begin as enthusiasts, and they consume blogs to fill the gap of this formal education because they don't have courses to take for electives. And blogs can give the impression, I don't know, I'm sure many of you read theme park enthusiast blogs, they give the impression that any opinionated person can design a theme park. And nothing could be further from the truth. And the educational experience needs to address this. The main options for delivering education would be majors, electives, and minors built out of electives, and case studies to be embedded in core courses. We can more or less take off the table the option of having a major in themed attractions engineering. I'm not a dean of engineering. I'm not sitting in the budget room with campus planning deciding what courses are viable, but I can smell that it's not a viable thing. Campus planning would never let it exist. There are lots of application domains that are bigger than this industry that don't have a dedicated major. So, I mean, if you're betting any money, I would bet against having a major in theme park engineering. So while the engineering curriculum is full, some of the above gaps might be, oh, wait a minute, I've gone too far. Some of the above gaps might be addressed by courses designed to qualify as liberal electives, because engineers have to take courses outside of engineering to show that they're well-rounded people and so on. So, and this is great because the art and story and business aspects of themed entertainment would be excellent liberal electives. Other gaps could be addressed by modules such as case studies or exercises to be put into engineering courses, like structures, for instance, the structure of a roller coaster instead of like a structure of a bridge. So those could provide good applications and examples to complement the engineering learning goal of engineering design, because all the accreditation programs require engineers to have some learning about design. So as I say, this is an interim report, and continued research is necessary to define the learning goals of what would we include in those electives and what would we include in those case studies. So the current stage is now consulting employers about entry-level and intern education gaps. If you are interested, if you are an employer of engineers or an educator of engineers, you can use the right-hand QR code to give me some input on a survey. The middle QR code is my email if you want to generate an email to me, and the blue left-hand QR code is just a link to my university website in case you want to get in touch with me. I'm not in the witness protection program. You can find me on the internet, and that's the easiest way to do it. And I made my time, Martin. How about that?